All right, starting on page 409, tests for parallelograms. Now, in the previous section, we learned that if a quadrilateral is a parallelogram, then, and then we had some conclusions. All right, flipping back through, if a quadrilateral is a parallelogram, then both pairs of opposite sides are parallel. Then its opposite sides are congruent. Then its opposite angles are congruent. Its consecutive angles are supplementary. If it has one right angle, it has four right angles. The diagonals bisect each other. Each diagonal separates the parallelogram into two congruent triangles. So we started by knowing that we had a parallelogram, and we concluded facts about the figure because it was a parallelogram. Now we're going to go the other way around. We're going to be given a four-sided figure, a quadrilateral, and then we're going to figure out ways to prove whether or not it's a parallelogram. Okay? So we don't start off knowing it's a parallelogram. We start off knowing that it's a quadrilateral. And then we have to figure out whether or not it's a parallelogram. Okay? So our learning target says to know and use the properties that ensure that a quadrilateral is a parallelogram. And we get started here on page 409. First, using the definition. If a quadrilateral has each pair of opposite sides parallel, it is a parallelogram, because that's the definition of a parallelogram. Okay? So the first test to see whether or not a quadrilateral is a parallelogram is to see whether or not both pairs of opposite sides are parallel. If both pairs of opposite sides are parallel, then that's enough to prove it's a parallelogram. But that's not the only way to determine whether or not a quadrilateral is a parallelogram. So we can also take a look at this. This first theorem in the box, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So both pairs of opposite sides parallel proves it's a parallelogram. Now we know that both pairs of opposite sides congruent proves it's a parallelogram. By the way, does it almost seem as if you already knew this? Because these are converses of what you learned in the previous theorem, or previous section. Okay? Previous we learned, if it's a parallelogram, then opposite sides are congruent. Now we're saying, if opposite sides are congruent, then it's a parallelogram. So we're learning the converses are true as well. So then the next one, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So all of these are converses. So we've got four good ways already to prove that a figure is a parallelogram. If both pairs of opposite sides are parallel, that does it. If both pairs of opposite sides are congruent, that does it. If both pairs of opposite angles are congruent, that will prove that it's a parallelogram. And if the diagonals bisect each other, that proves the quadrilateral is a parallelogram. And all four of those methods are converses of what we already knew. Okay? Now this next method isn't. It's a new method. This is not the converse of a previous one. And it says, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So, notice all the other ways. It was both. Both pairs of opposite sides parallel. Both. Both pairs of opposite sides congruent. Both. Both pairs of opposite angles congruent. Both. The diagonals bisect each other, so in other words, both diagonals are bisected. It was always both. It was always two things. Notice that this is one pair of opposite sides, not both pairs of opposite sides. One pair of opposite sides, but look, two things happen. That one pair of opposite sides is both parallel and congruent. So instead of having two pairs of things that are parallel, congruent, bisect, whatever. It's one pair, but two things happen. That one pair of opposite sides are parallel to each other, and they're congruent to each other. All right? And that gives us 5 methods to prove that a quadrilateral is a parallelogram. At the bottom of page 411, they sum it up for us. All right? And I'm not going to read through them again because hopefully I've just repeated these several times to try to get them in your head a little bit. Okay? But at the bottom of page 411. So, look here at the screen at this parallelogram and tell me when I have marked enough information on it for you to know for certain that it's a parallelogram. All right? So we do not know it's a parallelogram yet. As far as we know, it's just a quadrilateral. Is this enough to prove that it's a parallelogram? Nope. Is this? Yes, both pairs of opposite sides are parallel. That proves it's a parallelogram. Is this enough to prove it's a parallelogram? No. Is this enough to prove it's a parallelogram? Still no. Is this enough to prove it's a parallelogram? Yes, and really at this point, 2 different ways, right? Either we've got both pairs of opposite sides parallel to use that, or we have one pair of opposite sides parallel and congruent. Okay, so we would have our choice there. What about that? That. 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 Still no. We've almost got every different one, right? But we don't quite have any of those methods yet. Everybody following me on that? So, you know, the point being, you know, be careful. Don't assume that because it looks like a parallelogram that it is a parallelogram. Okay? All right. Let's do a couple from your assignment. So turn to page 413. Determine whether each quadrilateral is a parallelogram. Justify your answer. So if the answer is yes, our justification is going to be which one of those methods did we just use. If the answer is no, our justification is going to be none of the methods work. Okay? So, number 1, is that a parallelogram? Here we have one pair of opposite sides congruent, right? Now, even though those other sides, angles, one pair of opposite angles congruent, even though those other angles are congruent to the first two, they are congruent to each other, aren't they? So we actually do have both pairs of opposite angles congruent. So we'll say yes, and the reason is because both pairs of opposite angles are congruent. All right, number 2, is this one a parallelogram? No, it's not. Now, I'm going to stick with what I said before we worked one. If the answer is no, it's because none of the tests work. But that's kind of a generic answer because, how do I want to word this? When we were looking at this and we said none of the tests work, we don't know for certain it's a parallelogram. We also don't know for certain that it's not a parallelogram, do we? On this particular one, number 2, we actually know that it's not a parallelogram because of what we learned from the previous section. If it was a parallelogram, those diagonals would bisect each other, wouldn't it? Okay? So if you put no because the diagonals do not bisect each other, I'll count that right because it is right. Okay? But just to be kind of on the safe side, I guess, you can just say because none of the tests work. Okay? Because it's going to be kind of rare that they give you a situation like this one where I know for a fact it's not a parallelogram. Usually they're just not going to give me enough information for me to prove whether or not it is. Okay? All right, everybody still with me? All right, skip 3, go to 4. Find x and y so that the quadrilateral is a parallelogram. So for number 4, if number 4 is going to be a parallelogram, look at where they put these variable expressions. They put them as measures of angles. What do we know about the angles, or what do we know has to be true about angles in a quadrilateral to prove that it's a parallelogram? Opposite angles are congruent. Okay? If we set it up so that the opposite angles are congruent, that forces it to be a parallelogram, doesn't it? Okay? So what we want to do here is we want to set this pair of opposite angles congruent. So the measure 8x minus 8 equals the measure 6x plus 14. And then we also want to set up the other pair of opposite angles to be congruent. So the measure 7y plus 2 must equal the measure 6y plus 16. And then we solve each one. So to solve for x, you can follow along what I've done here. I subtracted 6x from both sides to get 2x minus 8 equals 14. Then I added 8 to both sides to get 2x equals 22. Then I divided by 2, and x equals 11. And then to solve for y, I subtracted 6y, then I subtracted 2, and y equals 14. So, you with me on number 4? Okay, on number 5, how are you going to set that one up? Same way, it's just sides instead of angles, isn't it? Okay? So opposite sides must be congruent. To make that a parallelogram, we must make it so that the opposite sides are congruent. So set up your two equations and solve them. And then check to see if you got what I got. Did you get x equals 4 and y equals 8? All right, so questions? Okay. A couple more examples. 6 and 7. So you got to turn over to page 414. Graph each quadrilateral with the given vertices. Determine whether the figure is a parallelogram. And then justify your answer with the method indicated. In fact, I may actually do the method indicated before I state my answer. Okay? So, number 6. So on your paper, just sketch out a coordinate plane real quick. Doesn't have to be very accurate because we're going to justify our answer. We're not going to go just by how it looks. I'm going to go ahead and use the grid I've copied onto the screen. But even then, that doesn't mean I'm all that confident that my drawing, if it's supposed to be a parallelogram, will look exactly like a parallelogram, and if it's not, then it won't. All right, number 6. Let's graph these points. A is -2, 5. So A goes there. B is 5, 5. C is 8, -1. And D is -1, -1. All right, so I'll go ahead and connect these up and make my quadrilateral. Let's see. So, do you think we have a parallelogram? Yeah, I'm thinking no. I'm thinking no. Now, they want us to use the slope formula to justify our answer. How on earth are we going to use the slope formula to justify whether or not that's a parallelogram? Not congruent, parallel. Okay? With the slope formula, I can figure out whether or not opposite sides are parallel. Now, what's the slope of AB? Horizontal line, so its slope is 0. What's the slope of CD? 0. So we do have one pair of opposite sides that are parallel, don't we? But our theorem says, or actually our definition says, both pairs of opposite sides have to be parallel for this to be a parallelogram. So it's AD and BC we need to worry about, isn't it? Okay? So let's find the slope of AD. It's been a while, so remember how that works? So I'm going to use A and D. Y2, -1, minus Y1, 5, over X2, -1, minus X1, -2. So I get -6 over +1, so I get -6. Now let's find the slope of segment BC. So Y2, -1, minus Y1, 5, over X2, 8, minus X1, 5. So that'd be -6 over 3. So that's -2. Are those two segments parallel? No. So, is that a parallelogram? No, because segment AD, now look at the screen here. You know, that means parallel. That means is not parallel to segment BC. And we've got our work supporting that the slopes aren't equal. We're good. All right, number 7. This time, make you another coordinate plane. And let's graph this one. You think yes or you think no? I think yes. Now, they don't want us to justify our answer using the slope formula. This time they want us to justify our answer using the midpoint formula. How on earth can we use the midpoint formula to decide whether or not this quadrilateral is a parallelogram? To see if the diagonals bisect each other. Because if the diagonals bisect each other, they go through each other's midpoint, don't they? So we need to sketch in each diagonal and we need to see if they bisect each other. Okay? So in other words, let's find the midpoint of WY, and let's find the midpoint of XZ, and let's see if they're equal to each other. Okay, midpoint formula, pretty easy. Add the x's, divide by 2 to get your x coordinate, add the y's and divide by 2 to get your y coordinate. So for WY, there's W, there's Y, add the x's, negative 5 plus 1, then we'll divide it by 2. Add the y's, 4 plus negative 3, and we'll divide that by 2. So for the x, negative 5 plus 1 is negative 4, and then negative 4 divided by 2 is negative 2. For the y, 4 plus negative 3 is 1. Well, 1 over 2, let's just keep that as 1/2. And then let's see whether or not the other diagonal has the same midpoint. So now I'm looking for the midpoint of XZ. So we add the x's, 3 plus negative 7, divide by 2, 4 plus negative 3, and we divide by 2. Well, 3 plus negative 7 is negative 4. Negative 4 divided by 2 is negative 2. 4 plus negative 3 is 1. 1 over 2 is 1/2. They have the same midpoint. So they go through each other's midpoint. Doesn't that mean they bisect each other? Yep, it sure does. So, yes, it's a parallelogram because the diagonals bisect each other. All right. Questions? What do you think? Doable? Oh, yeah. All right, so here you go. Page 413, 1, 2, 4 through 7, and then 9 through 14, 18, 19, 21, 24, 25, 46 through 49, 52 through 54.